So what I always do, right? First is recap of whatever we have done in the previous
Yes,
class.
sir. Yes, sir.
So I will keep revising so many times that it is embedded in your mind, right? You don't forget. Yeah.
Yes,
So
sir.
revision is the key, right?
Yes, sir.
Okay. So we learned that we can represent any vector. Right. So we can represent any vector like this, right? And then we learned that you can write the vectors in the Cartesian form. Cartesian form, and the Cartesian form you will have this kind of form.
Yes, sir.
And what is the magnitude of this vector?
Magnitude will be root of ax square plus ay square plus az square.
Right. So now you are you are very fast, right? Because we have revised this so many times. Right. And the
Yes,
direction
sir.
is represented by a hat, and that is a vector by e magnitude. Let me write not the vector one, right? So if I have an arrow that represents the vector, and if I don't have an arrow that represents only the line, right?
Yes, sir.
Okay, and then in the polar form, we understood that. We understood that we can calculate the resultant, which is a plus b. So in this Cartesian form, this would be very simple, right? we
Yes, sir.
add we add I with I, J with J, and then K with K, right?
Yes, sir.
And subtraction is also very easy, right? So subtraction is also easy in this Cartesian form. But we learned about this polar form. So in polar form, we had this two vectors, right? Which were making an angle theta with each other.
Yes, sir.
And then we calculated the resultant by drawing the parallelogram, right? So the resultant was a plus b, right?
Yes,
Addition
sir.
of vector. And what was the magnitude of it?
Magnitude. How do you say magnitude?
Yes.
We'll add like
Yeah.
if the value of we'll take the value of I square and I square, J square and K square in root.
Yeah. So that is there, right?
Yes, sir.
We don't have I, J, K. We don't have the Cartesian form. So this is the parallelograms law, right?
Yes, sir.
So in parallelograms law, what was the magnitude? Let me remind you this resultant triangle. So this was the resultant triangle. And then we calculated this resultant from the Pythagoras theorem. So this came out to be, remember?
Yes, sir.
Yeah, so this is, and the direction is this.
B sine theta by A plus B cos theta.
Yeah. So whenever it is not given this form, I, J, K, so you always use this form, right?
Yes, sir.
And then we learned about this subtraction of vectors.
Yes, sir.
So for the subtraction of vectors, we first find the opposite of, so this was A, this was B, and we reversed or we find the opposite of B, right? And then applied the parallelogram.
Yes, sir.
So then we found out the resultant, which was A minus B, right?
Yes, sir.
And what was the magnitude? Remember?
It was, yes, sir. Root
Yeah,
of A square plus B square minus 2AB cos
yeah.
theta.
Yes, absolutely right. So, okay. and the angle was
Angle.
just
It
remember
was
this diagram. So this is A minus B cos theta B sin theta. So whenever you remember this equivalent diagram, so then you can just calculate. Yeah. So this would be B
B
sin,
sin theta by A minus B cos theta.
right. So this is for the case of the subtraction.
Yes, sir.
Okay, this much we have done, and we have also done this resolution of vectors, right? So I will talk about this later also. That we can. So did you get the homework that I assigned? So did you get the homework? Yeah.
Sorry, sir?
So did you get any homework?
Yes, sir.
And did you try to solve that? No, it was difficult or
Yes,
you.
sir, it was little bit difficult. I tried.
Oh, okay. So we will discuss those questions. Okay, we will discuss
Uh,
those. Okay,
okay.
so in the resolution of vector, we learned that whenever we have some vector, so we can write this in the rectangular form. In the rectangular form, we can write it as AX, which is what? Yeah.
A cos theta.
Yes, 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 yes. And this is AY. This is what?
A sin theta.
Yes. So this was the resolution of vectors in a plane coordinate in 2 dimensions. We have x and y only coordinates, right? So this is
Yes, sir.
the resolution vector in a plane. Okay, we will discuss this later, but let us do some question based on whatever we have learned so far. Okay.
Okay, sir.
Okay, so you have two vectors. P and Q respectively. So find the angle between P vector and the resultant of, whenever I say resultant means the addition, right?
Yes, sir.
Resultant of P plus Q and P minus, right? So find the angle between P and P plus Q and P minus Q, right? So we find what would be the angle. You just calculate and tell me the answer. Okay.
Okay, sir.
Yes. Did you get the answer? Okay.
Trying, sir.
Yeah. So just remember that you have to find the resultant of P plus Q and P minus Q. Right.
Yes, sir.
Let me give you a hint. Let's say you have A vector and B vector. So what would be the resultant of these two vectors?
A vector plus B vector.
Yeah. So this is the okay.
So, but how can we find angle between resultant and P?
Yeah. That's interesting. Okay, let me give you another hint. Let's say I have a vector. Let me give you. So this one would be simple. Let's say I have a vector I hat, and I have a vector 4I hat. So what is the angle between I hat and 4I hat?
0?
Yeah. Yes, this is I, right? And
Yes, sir.
this is 4I. So did you get the idea?
Okay. Plus, minus, it means behind.
Yeah. So what is the angle you find?
180?
Okay, so let's say that you have to find the angle between P and resultant of these. So are you getting minus in somewhere? So let's say P vector is this, right? And resultant of P plus Q and P minus Q would be how much? This would be P plus Q plus of P minus Q, right?
Yes, sir.
So Q cancels and you have 2P vector. So what would be the angle between P vector and 2P vector? What would be the angle?
0?
Yeah, so the angle would be 0. Understood.
Yes, sir.
So how did you get 180?
Sir, because I thought it is plus resultant minus resultant, so total will be 180 because it will come in straight line.
Oh, so yeah. So if this is in the opposite direction, if the answer would have been, let's say, minus 2P, then the angle between these two will be 180, right?
Yes, sir.
Okay, so now let us do one more question. And remember that I didn't talk about, so in the subtraction of vectors, this idea is used in relative velocity, right?
Yes, sir.
So I will talk about this more extensively in the third chapter. So whenever I will be doing this third chapter, so I will talk about relative velocity. So in relative velocity, you use this subtraction of vectors. Okay,
Okay, sir.
let's say I want to calculate the relative velocity of A with respect to B. So this is simply VA minus A. So you see that there is a subtraction involved, subtraction of vectors. So yeah, we will see that whenever two cars are moving and we have to find the relative velocity of cars or the relative velocity of trains. So we will use this subtraction. Okay.
Okay, sir.
Yeah, so let us do one more question. Let's say that the resultant of vector A and vector B is R1, right? And by reversing the direction or by reversing the vector B, the resultant from out to B R. Then we have to find R1 square, R2 square. Did you understand the question?
Yes, a little bit.
Yeah. So you have two vectors, right?
Yes, sir.
And the resultant is R. So R1 is A plus B, right?
Yes, sir.
And by reversing the vector B, reversing meaning that we have this B. So
A minus
reversing
B.
means minus. Actually, this will be minus. So the resultant of A And minus b would be a minus b, right?
Yes, sir.
Now you tell me that what would be r1 square and r2 square.
Okay, sir.
Just find out and tell me what it is.
Yes, sir. Finally.
So you see that these are magnitudes, right? R1 is the magnitude, R2 is the magnitude. So just think about the magnitudes of the vectors.
Okay, sir. Sir, is it 2a vector square plus 2 vector b square?
Vector,
Yeah.
you are only talking about the magnitude, right? Vector A square is A square magnitude, right? So, yeah, your answer is correct. So, A plus B, R1 magnitude would be how much? This would be A square plus B square plus 2AB cos theta, right?
Yes, sir.
And R2 would be how much?
A square plus b square minus 2ab cos theta.
Right. And we have to find the sum of these squares. So R1 square would be simply R1 square plus R2 square would be A square plus B square plus 2AB cos theta plus A square plus B square minus 2AB cos theta. Right, so this one cancels, and as you say, 2A square plus B square. Right.
Yes, sir.
Okay, so you have already done this, so you don't need to note down this part, right?
Yes, sir.
And let us do another question. So this question is that if the magnitudes of resultant of two vectors is equal to the magnitude of the subtraction of vectors, find the angle between the vectors. Okay, try this question. What is given?
Yes. The magnitude of resultant of two. The two vectors, like their magnitude are equal. Resultant.
Yeah. So,
Magnitude of resultant equal.
so magnitude of resultant is A plus B magnitude. Right.
Yes, sir. To magnitude of subtraction of vectors.
And this is equal to what?
Subtraction of vectors. Magnitude.
Yeah. A minus. Right.
Yes, sir.
So now you find what is the angle between two vectors, right? So you have two
Okay.
vectors. This theta you have to find A and B. So A plus B magnitude and A minus B magnitude is same. This length is same. Right.
Okay,
So
sir.
Done, Akhil?
Doing, sir.
Okay. Yeah, stuck at some point.
Yes, sir.
Okay, so let me. So A plus B magnitude would be how much?
Math.
Yeah, magnitude of the resultant of A plus. This is how much?
So we should use the formula, right? A square plus
Yeah,
B square.
yes, yes,
2ab.
yes. So that is the magnitude, right?
Yes, sir.
So this is A square plus B square plus 2ab cos theta. And it is given equal to what is A minus B magnitude?
A square plus B square minus 2ab cos theta.
Right. So this is okay. Now we can, so both in the both side we have roots. So we can square them, right? So squaring both
Yes, sir.
sides, yeah, squaring both sides, we will get A square plus B square plus 2ab cos theta equals to A square plus B square minus 2ab cos theta. Right. So A square cancels, B square cancels. Right.
Yes, sir.
And we have A to AB, and this is, so this is 4ab
4ab.
cos theta is equals to 0. So 4 cannot be 0, right?
Yes, sir.
A and B are not 0, so this goes in the this side, right hand side. So cos theta is 0. Right. For what angle of theta this cos angle is 0?
Cos. And cos.
Yeah.
The cos
Cos is
90.
cos is decreasing 1. Just remember cos is decreasing 1.
Yes, sir.
So what is cos? Cos 0 is, oh, cos 90.
90.
Yeah. So
Yes,
theta is. Right. So the angle between the vectors is 90. Understood?
yes, sir.
Okay. So just note down this part. Do you want to note down this part? This question.
Yes, sir. Finish.
Finished.
Yes, sir.
Okay, okay. So now we have done the subtraction, the addition, and the combination of addition and subtraction. Let us do the questions of this resolution of that. Let's say that you have, so what was the homework? Let us do first the simpler questions, right? So we have, let's say this is X, this is Y. So we have this 15 Newton force, right? And the angle is, let's say, 60 degrees. Okay.
Yes, sir.
So this we can represent this in the Cartesian form, right? We can resolve this vector in two components. So one would be this AX component, the other one would be this AY component, right? So
Yes, sir.
AX would be how much?
7.5 I cap.
So, oh, we already did this question. Yeah.
Yes, sir. Yesterday, last question, this was done.
Oh, so let us change the value, right? Let us just change the value. This is 20 Newton and this is 30. Okay. So now you tell me what would be the vector. What would be this vector? What would be this force?
Yes, doing.
Okay. So please find the x component, and we have to find this x component also. F would be simply fx I hat and fyj. So we need to find
Sir, 15
fx.
root 2.
15 root 2.
15 root 3.
This is 20 Newton. 20. Okay, so 15. Yeah, so
Oh, 10 root 3. 10 root 3 then.
yeah, so fx is 20 cos 30. Yeah, so this is 20 root 3 by 2. 10 root 3 as you said, so 10 root 3 I. And what is y?
AY sines 30.
20 sine.
1
right?
by 2. 10,
So
sir.
10. So this is 10. Now you understand that we can resolve any vector in this
Yes.
Cartesian form, right? So what was your
Yes.
homework? What was your homework? The homework question was, let me draw
Sir,
this.
they were telling to find force vectors, angular vector, velocity vector, momentum vectors.
Okay, so before we do that, let us do this question. We have this question, right? So this is 37 degrees. This is 37, right? And this is 10. Okay, and we have this. This is 60 degree, and this is f1, and this is f2, which is 4 Newton.
Yes,
Right.
sir.
Okay, so there is a peculiar property of this 37, right? So sine 37 is 3 by 5, and cos 37 is 4 by 5. This just remember. If we have this 3, 4, 5, so yeah, 3, 4, 5.
Okay, sir.
3, 4, 5. So this is 37 degree, right? So sine 37 is 3 by 5. And cos 37 is 4 by 5. Okay.
Okay, sir.
Yeah. So we have to first resolve this vector. Okay.
Yes, sir.
So first find out the vector of this part. This f1. What is f1 vector? This would be f1x I hat and f1y j hat. So what is f1x?
F1x. That would be 10 Newton
Yeah.
by 10 Newton into cos 37.
Yes, absolutely. So 10 cos 37, so 10 into 4 by 5. So
8,
8.
sir.
Right. And what would be f1y? So this would be 10 sine 37, right? So this
Yes, sir.
is 10 into 3 by 5. So this is 6. So what would be the vector? 8i plus 6.
Plus x j.
Right.
Yes, sir.
So yeah. So then we can find f1. Okay. And you tell me what would be f2.
F2.
Yeah. So there is important thing that we need to take care of for the case of f2. So we have to be careful with this f2 part. So first you tell me what is f2x.
F2x will be fx minus I cap.
Yes, of course. Yeah. This was the important thing, but we have to find this is 4 cos 60, right?
Okay, 4. Okay, sir.
Yeah, so 4 and root 3 by 2. So this is 2
2
root
root
3.
3.
And we have this f2y, which is 4 sine 60, right? So this is 4 and 5. So 2. right?
Yes, sir.
Now, this would be f2x, but f2x is in the, so this is f2x, right? But this is in which direction?
This is negative.
Yeah, minus or pi, right? As we
Yes, sir.
see. And again, we have this f2y, which is in this direction, right? So this is
Yes.
which direction?
Minus j. Yeah.
Zero. Right. So, and now we know the value of, so this is 2 root 3 minus I, and this is how much? This is 2 0. Understood?
Yes, sir.
So you can see that what is the usefulness of this resolution. So here comes the usefulness of this resolution. You can see that we have changed f1 in the form of Cartesian form and f2 in the Cartesian form, right?
Yes, sir.
And now we can calculate f1 plus f2 pretty easily, right?
Yes, sir.
We can find the resultant of this f1 plus f2, correct?
Yes, sir.
But for the case of the parallelograms law, so applying the parallelograms law in this case would be difficult, right?
Yes, sir.
So that is why the resolution of vectors is very important. This helps us in resolving this in the Cartesian form. And in the Cartesian form, we can easily solve the addition and subtraction, right? So you please note down this question and then we will move on. Okay.
Okay, sir.
Today I didn't go ahead because Afaf and Ishita were not here, so that is why I did only the question, right? So this will clear your idea about these topics, right?
Yes, sir. Yes, sir. Clear. 2y. Finish, sir.
Finished. Okay, now so I need to determine resultant of system vector. Okay, so this is the question. Now you see the homework question are easy or tough. Can you say now? So this was the first question. This is 30-degree, right? This is 30-degree and this is 610 Newton. And this is 500 and 40-degree. Okay, 40-degree, but we don't know. This is 40-degree and this is 500. Right.
Yes, sir.
This is, let's say, F1 and this is F. So we have to find F, which is F1 plus F2. This is the question, right?
Yes, sir.
And the important part is that we calculate or we resolve the vector with the horizontal. So we know the x angle, right?
Yes, sir.
So this is the horizontal, so we need this angle. So this is 40, so this would be how much?
180 minus 40.
Oh, this is 90,
Okay.
right? So this is
50
50,
degrees, sir.
right? 50 degree. Now we can resolve this F1. So F1 x would be how much? 500 cos of this 50, right?
Yes, sir.
So we don't know the value of cos 50 degrees, so let's keep it there. And F1y is how much?
F1y. 500 sine 50.
Right. So sine 50. So we don't know the value of sine 50. So yeah. And so we can write F1 vector as 500 cos 50 I hat plus 500 sin 50 j hat, right?
Yes, sir.
And now you tell me what is F2x.
F2x, it will be 610 cos 30 degree.
Yes, correct, absolutely correct. So we don't, yeah, we don't value of cos theta. So this is 610 root 3 by 2. So this is 305. So 305 root 3, right? And
Yes, sir.
F2y would be how much?
F2y, it will be 610 sin 30.
Right. So this would be simply 305. Right.
Yes, sir.
And now we can write F2. So F2 is 305 root 3 I hat. And what would be the sign here? So this is 305. What would be the sign? J or
J,
what? No,
J,
no.
sir.
Look here and then tell. Right. So this would be
I,
F2x
K,
and
K, K cap.
A. Yes. We are in a plane, right? Only X and Y. So this is
This will be F2.
yeah,
This will be
F2Y. Yeah, F2Y.
Fx.
This is which direction?
This is Y, sir.
Yeah, this is J, right?
Yes, sir.
So this would
Minus
be
J cap.
minus, right? Understood.
Yes, sir.
So this is 3 root 5 I hat minus of 3 5 J. Okay, and now we can calculate what is X. So F is F1 plus F2. Understood. So this would
Yes,
be
sir.
5 cos 50 I hat plus 500 sine 50 j hat plus 305 I hat root 3 I hat and minus of 305 j. Okay, so this would be how much? 500 cos 50 plus 305 root 3 I hat and plus 500 sine 50 minus 305 j. Right, this would be the answer. If we can calculate what is sine 50 or cos 50, so then our answer would be simple. Right.
Okay, sir. Yes, sir.
So you see the value of what is cos 50, calculate from the calculator and then plug into that. Okay, please note down this question.
Yes, sir.
Done.
No, sir. Writing F2, vector
Okay.
F2 part.
Okay. So this was the first homework and yeah, so hopefully in the next Saturday and Sunday, I will be able to finish this vector part and then the differentiation and integration. Then I'll
Yes,
start
sir.
Done after.
Little bit left, sir.
Oh,
509 minus 5, 305 J. Yes, sir, finished.
okay. So that is why we needed this resolution of vector, right? It is a very
Yes,
good
sir.
idea, and from this we can easily calculate the result. Okay. Yeah.
Yes, sir.
So the second question was this was the second question. 3 radian per second. So angular velocity vectors. Okay, one vector was this 25. Why they are giving us these kind of parameters? Right,
Yes, sir.
because we don't know the value of these. Second, and the other vector is. So this is 30. Okay, and 400 rads was right.
Yes, sir.
So this is let's say angular velocity. This is represented by omega. Right, so let's write it as omega 1. This is omega 2. Okay.
Okay, sir.
So first we'll find out what is. So this is not with the horizontal. Right. So what would be the angle with the horizontal?
180 minus 25.
No, 180, not negative.
Sorry,
So
90 minus 25.
90 minus 25. So this is 65.
65,
right?
sir.
Right.
Yes, sir.
So 65 is the angle, and the omega 1x would be how much?
Omega x1. 300 cos 65.
Right. So 300 cos 65, and omega 1y would be
300 sin 65.
right. So omega 1 vector would be simply 300 cos 65 I hat plus 300 sin 65 G, right?
Yes, sir.
And omega 2x would be how much?
Omega 2. That will be 400 cos 30.
Right, correct. So
Yes,
this
sir.
is 400 root 3 by 3.
Root
So
3 to
200.
200 root 3.
And omega 2y would be 400 sine 10.
Yes, sir.
Right.
200.
So this is yeah. 200. Okay, so this is 200, and then omega 2 vector would be 200 root 3 I hat minus or plus?
Plus, sir.
Look again.
Okay. Vector 2. Omega 2. Okay. It will be
Yeah,
minus.
so minus. So this is minus I. And what about this J?
Minus J cap.
Yeah. So again minus. Right, and then omega would be omega 1 plus omega. Right. You calculate
Yes.
and you are find out. So please note down this part, and yeah, so we will meet in the next class, and then we'll go ahead. Then we will talk about this multiplication of vectors. Okay.
Okay, sir.
So please note down this part.
Yes, sir. No time. Um, Omega 2.